All right, guys, Mr. Antonucci here, and we're on part 3 of section 8.3. And this time we're going to talk about what's called the washer method. This is a situation where you have a region that you're rotating about the X or Y axis, but the problem is it's bounded by two functions. One function bounds the top and one function bounds the bottom. The same process is going to hold true. The first thing we'll do is draw the region, take a vertical strip, rotate that strip around, you get a circle with a hole in it. Now, the area of a circle with a hole in it is pi times the quantity, I'll just write it here, of big R squared minus little r squared. Okay? Because that comes from pi big R squared minus pi little r squared. Now, one caution with this, and I see students do this from time to time, is they'll mistakenly do pi times big R minus little r squared. Okay, so just be careful there. You want to think of it as you're subtracting the areas of the outer circle and the inner circle, because you have essentially a ring or a washer, which is a circle with a hole in it. The thickness is going to be dx or delta x here in this case. And then to get the volume of the whole solid, you would add up all the strips, take the limit as the number of strips approaches infinity, and you would end up with the definite integral. Now notice it's pi times the definite integral of big R squared, which is the outer function, minus little r squared, which is the inner function. Okay, so here's the formal definition right here. Let's do an example. We want to find the volume of the solid of revolution generated by revolving the region bounded by y equals 2 over x and y equals 3 minus x about the x-axis. So the first thing we need to do is to find where the region begins and ends. So we would set 2 over x equal to 3 minus x. You'd have 2 equals 3x minus x squared. So you'd have x squared minus 3x plus 2. Set that equal to 0, and you'd have x minus 2, x minus 1. So you'd end up with x equals 1 and 2. So this is the region right here. If we take a representative strip in that region and rotate that strip about the x-axis, you would get a big ring like this. Okay, now you have to figure out what makes the outer radius and the inner radius. The outer radius is given by the line, which is 3 minus x, and the inner radius is given by the curve, which is 2 over x. So now we can set up our definite integral for this situation. So the volume is equal to pi times the integral from 1 to 2. And here again, if you're on the AP exam doing a free response question, which historically there's almost always some kind of volume question on the free response section, you have to show how you got the limits here. If you have to do it by hand, you have to show the work. If you can use Desmos, you have to show the setup of the equation and then the answers. Okay, you can solve the equation using Desmos, and we'll go through an example like that as well. So then you can set up the integral, pi times the integral from 1 to 2 of big R squared, so 3 minus x squared, minus little r squared, 2 over x squared dx. Now, a lot of times on the exam, they will ask you to set up the integral that represents the volume, but not always evaluate it. You may be asked to evaluate it. In this case, if we had to evaluate it, first thing we would do is FOIL the 3 minus x out and then square the 2 over x. All right, so you'd have 9 minus 6x plus x squared minus 4 over x squared. And then we could anti-differentiate that. So you'd have pi times 9x minus 3x squared plus 1/3 x cubed cubed plus 4 over x. And then we're going to evaluate that at 1 and 2 and subtract. What you'd end up getting is pi over 3 for this one. All right. So now, next thing we want to do is just try another one. Find the volume of the solid of revolution generated by revolving the region bounded by the graphs of e to the x and this graph, negative x squared minus 2x plus 2, about the x-axis. I'm going to show you how to do this on Desmos and what to put for the work on the AP exam. All right, so in Desmos, I would put the first function as f of x, so that's equal e to the x, and the other function as, name it, g of x. So we would have negative x squared minus 2x plus 2. Now you could see our region right here already. I could just click here and get the intersection points. Put them over here. So what I would show for my work here is that e to the x equals negative x squared minus 2x plus 2. X equals 0. No, I'm going to do the negative one first. Negative 2.71279. I'm going to call that A. And x equals 0.28987. I'm going to call that B. Okay. Now the volume is going to be pi times the integral, and you could do this from A to B, and I recommend you do that because you don't want to change some of the values in the limits and get it wrong because you wrote down the wrong number there. Okay. Now, if we look at this region, okay, a vertical strip, and you rotate it about the x-axis, the top is going to be formed by the parabola and the bottom is by the exponential. So the big R is negative x squared minus 2x plus 2 squared minus little r, which is e to the x squared dx. So if I'm in Desmos, what I can do is type in pi and then integral from negative 2 point, almost did the wrong one, 71279. And then you could actually copy and paste that in there. Okay. Then I'm going to 2 parentheses. One parenthesis is going to contain the whole integrand. The next parentheses is going to be my big R squared. My big R squared is the parabola squared, which remember, I named the parabola g of x, so I could just call it g of x and then square that, minus little r squared, which is f of x. Put your dx on, and you get 48.550 042 blah 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 blah. And if you were asked to get this as an exact answer, then it would probably be on a non-calculator allowed portion of the exam. So for your answer over here, however, if you're talking on the AP exam, then you could just put 48.550. Okay. And this is all the work you would have to show. You showed the equation that you solved, the limits of integration from the solutions to that. You set up the integral. We named the limits A and B so we could refer to those down here. And then our answer, because you're allowed to evaluate a definite integral on Desmos. You're allowed to solve an equation on Desmos. And that's all we really have to do for this one. All right, guys, that's it. Hope that was helpful to you. Reach out if you have any questions. Take care.